alert. That's cool. So, do I do it here or do I do it here? Do you know your database? Or better yet, you don't need to know your database. Do you know where you'll be stored? Find all references. Maybe a property drawer would be ideal for this. So where are you declared? So piece data. Piece data drawer. No, I think this would be best. Let me go into the slab creator. I think if we use an attribute, we'll be better off. So you define slabs, pieces, excuse me. Trying to see wherever a piece is defined, you can just add an attribute. Attributes work, that's what they're for. Okay, so maybe database item. And I think you can tell it the name of the database to load. Gosh, is that right? It actually doesn't take a lot to create a property drawer, so don't have a lot to worry about. So let's do that. We have too many database keys. Let's grab a database item, and we're going to use that database item, and it's going to take a string, and that would be the database name. And this is the real name, the one from the actual asset, what you see in your project view. Itchy ear. Maybe I need a new mic because I don't need to be actually wearing headphones. I'm starting to bug my ear. Okay, that might work. So public read only string of database name. I love it. And we'll set that in the constructor. Qualify that, and let's get a proper name going on here. What's going on, Bob the noob? Nah, I'm not there yet. I'm in this infinite runner getting beat up by identifiers. That should be here in about an hour or so. We'll start tinkering with that project. Okay, so now we can identify the data. Let's grab the database. Just need the name and see if this works. Alright. So now we're passing in the database name directly from the asset. So in the drawer we're going to read the data from the resources folder. And that way we should be able to select them. Oh, this is driving me crazy. Hang on, that's not where I need that. I need that right there. So a database item. Alright, let's give that a shot. I'm a little embarrassed to not even know that it's that game PC or what. Just a tad embarrassed. Alright, yeah, you guys entertain yourselves because I'm in a lot of trouble here. Okay, so let's reduce this drawer to a database item attribute. Yeah. Okay, so that should be a database item attribute. Okay, so now what happened here? We get the attribute, which we can pull. I don't think we'll be using any of this right now. Or we'll start with the rough sketch. Alright, so I should just do this right. Database item attribute. So now that'll convert the attribute that's coming into our attribute, and Clash of the Clans. That's what you guys play? Clash of the Clans? Oh. Okay. Okay. Alright. Yeah, just hang out. Get me hip. So see, we gotta have our database name. So that's how we're gonna identify it. So now let's see if resources, if we can load something by the name. So it takes a path or a type. Okay, that ain't good. How do we get a concrete type? So we can't get a concrete type. We're gonna have to yeah, we have to do too many crazy conversions. So we have a path as we see here, but it's asking for a type, and you can get a type from the actual name, but then you don't get a type back. Is that, you wait a minute. Yeah, we still don't have access to that type. Gosh, that's what my actual library did, solved all of this problem. And that's why I was using it. So now I'm trying to recreate all this stuff from scratch, but easier, or I should say less complex. So we can get our database name. Why are we having problems drawing it? Heading to my piece behavior here, and here's the database. Okay, we can convert it like before to a has identifier. So we get a string back. You know what I think we should return from has identifier? I think we should return two things: a string and an index. those are the two items that we absolutely need to identify each of those things. The type, we're, we're not concerned with the type right now, because the type we can do with in its own class. So I'm going to modify has identifier, and we can't just declare we need a key pair. So this is what I'm thinking of here. Define a public class key set. Is that a class that is defined in C#? I don't think so. I don't think so. So then we're going to return a key set as our identifier, which is public string name and public int ID or index. I'm sorry. Index. So that's its location. Index IDENTIFIER. So we get a key set. I'm gonna rename it. Why not? How could it hurt? Okay. You get a key set. The key set is an index and a name, and that's easy enough to return here in the. Oh, we need an array of keys. Okay, now, as I was saying, that's easy enough to return here because link makes it easy again. Okay, so this method would give us I think we can kind of go anonymous. So if I do that and that, okay, so I have a problem with that. String piece identifier, only assignment. Okay, I know what that's all about. What did we call it? Key set. And do you need to do this? I thought there was a way of like setting it like that. So what is this? If I send in a piece data, I won't be able to. I could just get the name. So here we have the identifier. Let's get the index from I, and then we create our constructor. Sweet. I like how they don't use the values you have, but something else. At least it's something. They give you a pretty nice skeleton at least. Can't complain about that. Should be here somewhere. Okay, that looks good. And I think we need to serialize this stuff. Systems serializable, and the fields will serialize because they're public. Okay. So this is, we return our key sets. I thought the names would be the same too. Okay, so where's our next database? Let's find that thing. Let's find that thing. Beautiful. So here's our next database. It's the slabs. We select slabs and we return a key set of slabs. We're using this anywhere else? Okay, so far so good. Now we need to get into the drawer and make sure. Wait a minute. I'm looking in the wrong drawer. Yeah, that should be an error. That's fine. Okay. So, that's an entire array there. And it was an array of strings. So we don't have link here. I'm going to go ahead and import link. We'll do the same basic thing. And that way we can pull only what we need out of here, and that's the string. So like x, return x dot identifier. Whoops. X dot name. Oh, I thought it was gonna do it for me. So to array. Okay, so that's back where we started, but we have a little bit more information in that has identifier. So now we can get the database by name and we can convert it to what is that? To a has identifier, and then we can pull the index and the name out of the data. So here we go again. And this says what? Blown pieces and divine key set get is an accessor not found in interface member. I don't have a get. Said I have it misnamed here somehow. Key set. Okay. It's a case thing. There we go. So that should clear that error, and we should still get the same behavior. That shouldn't change where we were. Right? So we should still be able to select all of them from the list. We got a nice little space here. That's that new drawer we're implementing. All right. So it's a little more encouraging. Yeah, this is a hot mess. Okay, so now we can load the database. So resources dot load. We give the name and the type. So the type is I has identifier. I has database. Nope. I has identifier. Let's use this type. It might load, or we can load it as a scriptable object and then convert it. That might be a better option there. So we can even do it like this then. So let's load up the scriptable object and see if it converts to IHAS database. Well, IHAS identifier. Oh man, that'll be so cool. That'll save me a bunch, and then it'd be something totally different because now I would I'm not gonna say anything because I'm usually wrong. So we have our key sets here, and we can. This is the identifier written inside of the data, the piece data and the slab data. So it's a string, but we need to be able to select all of them, which we have them here now, and draw one of these pop-ups with that data. Right? So if we has identifier, we do this. Right, so if we has an identifier, we select. Oh, we need some link in here. I hope this is successful. It'll be really nice. So if we has identifier, we do that. We get the serialized object property. We can't add. We need to add a database reference. This is a little misleading, but at least it's in error. We can fix that before we get started. So we have an item drawer. Let's see if it breaks things. It's an actual drawer. It's referencing something. So this spins up. It's referencing something in the slab. Oh. Type is not supported. Error. Serialized property, int value, error. More? Yep. Oh, look at that. Okay. Promising. Yeah. Look at that. All right. So these are actual pieces, right? Because these for the big guys we have that, and for the small guys we have that. It's just tons of errors. Int type not supported. Okay, so in here, oh, we're not using. We are a string. So we need a var. I'm sorry, an int. Let's do that. We'll take the int and we will need to find out if which one's selected, right? Because it's almost certainly that it's not the first one that's selected every time. So to do that, again, we use the same set that we have. We get the set and we get the index. Index. Hang on. How do we get the index? Where? I'm not sure if where works like the select, where you can get the indices out of it. Hang on. I'm going to run this query, and we'll select it from this query. So it's saying no. We select the name. From the index. Where x is a key set dot name equals, we could use a equal for this, but the property prop dot string value. Then we select it. So what is this giving us? It's giving us a bunch of them. If it's an array, can we just find the index? Jeez. Gosh. I like find index. It's concise. Oh, it's a list. Hang on. It's a list. Let me to-list this. Out of curiosity. Might be an easier way to pull this data out. Yep. So let's find the index. And we'll use the same predicate we described for the where clause. And that'll give us an int. And then we use that to pass in. And speaking of which, since we have that integer, if it's a negative one, it will fail. So I'm gonna leave this as I was gonna just select the integer and use this value as the index. But I'll leave this query here. This is the index. If it doesn't find the index, it returns -1, and it's out of bounds. So those errors should go away. Okay, so here we have a choice, and we can select them now. And also here, I'm wondering why they're all. Okay, still, it's better. So why it's not changing, I'm not sure. Let's figure that out. So this is where the change should occur. Oh, it never finds the name, which is fine. But how about, oh, we need to track the changes. So let's find the last index. I'm sorry, that's index last value equals this thingy here. And if there's a change, I know, I missed something. So if we do have a change, we need to go back the other way. So if we have a change, we need to set our property string value name. This is our identifier, equals has identifier key set int value, and the identifier, that the name, I'm sorry, that's referenced in there. So that will give us a change once we change. Yep, doesn't show on stream the cross fingers I got here, but they're there. Ooh, let's do number 3. Yay. Sweet deal. Is it still there? And there we go. Alright, so we eking it out here. Slowly but surely. So we have a hole for peace. It should still be a hole. Sweet. Alright. So now we have a way of selecting our items from the database. Say it's a database item. I was just thinking maybe we can use the same formula here for the database key, and in the actual code you can check. Okay, for this particular code, the selected index is embedded on the object, so it I guess you pick through that index to give you the one that you've selected. But we can also use that same behavior to draw the actual things you're selecting, like so. here we're doing the opposite in both of these cases. Oops, grabbed the wrong one. So in this case, we're drawing the string value, and in this case, we're drawing the integer value. Right, so that's the difference. We're drawing the same type of value from the same data, but we're using two different representations of that data. We need the string so we can read, because we can't read we can't read those dang numbers. So effectively what this does is it turns strings into enums, right? And if we're careful in the way we code the rest, well, this is the type of thing I've done before, and this is kind of where I'm headed, but it's much simplified, like I said before. And if, like I was saying, if we continue to code and we code carefully, we can have pretty good behavior, and that mimics an enum. So, and even as type safety in certain circumstances, we can mimic that with attributes, property attributes. Right. So now, here I don't have to type in flat or anything, and in code I wouldn't have to do it either. Okay, so